All right, these notes today are on a new exponent rule that we haven't looked at yet, which is called power to a power. So real quick, let's remember that this variable on the bottom, we're always going to be calling the base, and that these two exponents up here are, well, I already said it, right? These are our exponents. Okay, the a and b represent the exponents. When you have only one base like this, and you have an exponent on it, and then also another exponent outside parentheses, right, that's key, then we are using this rule here, okay? And what happens is our exponents, instead of getting added like we learned last time, when there's an exponent outside an exponent, right, we call this power to a power, they get multiplied. So a times b, right? And we don't really need that dot there, so more often than not, you're going to see it look just like this. Okay? So this is the rule for what happens when we've got power to a power. Let's look at the first one. The way that we used to do this was we would have taken x squared and we would have written it out 3 different times, right? Like this we wouldn't have written as this, we would have had it look like this with what we used to know. Okay, or I should say with what we did last time. Right, and we would still get the correct answer, right? We would add up all of these exponents and we would get x to the power of 6, right? This way still works, it's still good. However, what we want to try and get to is a new method of doing things, and that's this power to a power rule. So it looks very similar to this rule that we just learned. So if we've got x to the power of 2 cubed, these exponents are just getting multiplied. So we're going to have x to the power of 6, right? As I said, they did turn out to be the same thing, and that should, of course, happen every time. All right, on problem 2, if we do it how we used to do things, we would write 2a to the 5th times 2a to the 5th times 2a to the 5th times 2a to the 5th, right? And now we've got all these 2's in the front. So 2 times 2 times 2 times 2 is going to give us 16a. And then we get to add up all of these exponents. 5 plus 5 plus 5 plus 5 is 20. So 16a to the power of 20. And this is the correct answer. But our new rule, our power rule, lets us solve this in a slightly different way. So here we go. We've still got 2a5 to the power of 4, and I'm going to do it a little differently. Okay? The main idea to understand is that everything in the parentheses is to the power of 4. The 2 is getting to the power of 4, and the a to the 5th is getting to the power of 4. Here's what I mean. All right? We can think about it as the 2 getting our new exponent on the outside, and our a to the 5th also getting that new exponent on the outside. Right? So this 4 can kind of distribute to these exponents. Now this does not always work, you guys. It only works when we are doing this to a monomial, right? There's only one term inside, even though it has a's or could have a's and b's or whatever. All right, so this is going to give us 16, right? 2 to the 4th is 16, a to the power of, now what are we doing with these? Our new rule tells us we can multiply them. So it's just a shorter way to get to our answer. Okay. All right, I'm not going to do the blue examples at this point. We're just going to stick with this new rule, right, the red examples. So everything in problem 3, the -6 and the y to the 4th power are being squared. So I'm going to write it separately to help my brain a little bit. I'm going to think about it as -6 getting squared, and also y to the 4th power is getting squared. Okay, -6 quantity squared is going to be a positive 36, and y's new exponent is 4 times 2, which is 8. Okay. Problem 4, all that's different here is you don't have a number that you're used to, you have a fraction. It's still the same thing, right? The 1/2 and the m to the 7th, everything inside, again, is being squared. So we're going to rewrite it. 1/2 squared to the power of 2, m to the 7th, to the power of 2. Now this right here, if you guys aren't comfortable with this, just remember that your calculator can help you do this. If you press alpha, y equals, this first option here is numerator, denominator, and that's the one we want, so I'm just going to click enter. All right, so I can put in here You know what? I should have done parentheses first, just like on my paper. All right, 1 on top, 2 on bottom, and I'm doing all of this to the power of 2. All right, and so I get 1/4. So I know that this is 1/4. M to the power of, these get multiplied, and I get 14. Okay. In problem 5, they're doing something a little bit different because they have a bunch of different variables in here. Not a bunch, I guess they just have an extra one here. They've got x and they've got y. But again, every single term in here, every single variable and coefficient, all of it is getting to be to the power of 3. So the 5 we're putting to the power of 3. The x we're putting to the power of 3. And the y cubed we're putting to the power of 3. All right. This is something our calculator can do for us, or some of you might know off the top of your head. 5 to the 3rd power is 5 times 5 times 5, which is 125. All right, x cubed, we're missing an exponent right here. Okay, so like here we have the 3 and the 3. Here I only have one number, so I'm going to use the number 1 just to keep my brain straight. So we're going to have x to the power of 1 times 3, which is 3, and y to the power of 3 times 3, which is 9. Okay, and that's it. And then last but not least, if they tried to, if you saw this kind of a rule, if you were to apply it in a word problem, it'd probably be in a volume of a cube problem. All right, because if you think about a cube, right, it's a bunch of squares. Okay, that's like by definition, that's what a cube is. So if you know that this one side is 3a cubed b to the 4th, like they give us, then you know that all the sides, in fact, are this same length, right? All of them. So we're going to use that fact. We're going to remember that volume of a cube is length times width times height. And in this case, because they're all the same side, we can say the side times the other side, right? Because those are all the same lengths in a cube. And so we're going to think about the volume of a cube as s cubed. And this really allows us to use this new rule that we've been talking about. So the volume is going to be the side 3a3 b to the 4th cubed. Okay, I'm going to say it again. It bears repeating. Everything inside of here is being cubed. The 3, the a cubed, and the b to the 4th power are all being cubed. So we're going to think about this as 3 cubed, a cubed cubed, and b to the 4th cubed. Okay. 3 cubed is 27, right? 3 times 3 times 3. A has a new exponent, which we get by multiplying, and we get 9. And B has a new exponent, which we multiply together to get 12. All right, so this is my volume of a cube. All right, y'all keep in mind that you can do all these problems in this way, but that'll get old real fast if you've got a high power on the outside of your parentheses. So we like this power to a power rule for that reason.